السلام عليكم ورحمة الله. Welcome to Math Cinema. النهاردة هنتكلم عن موضوع مهم جدا وهو applications for the derivative. First of all, don't forget to support my channel, like and subscribe. So the applications for the derivative are: number one, determine the inclination of the tangent of a curve at a given point. لو انت طالب في تانية ثانوي فالمفروض ان انت اخدت الابليكيشن ده، ان احنا عندنا الديريفاتيف بنقدر نحدد بيه الانكلينيشن of the tangent. فلو احنا عندنا y equal f of x is a curve، طبعا اللي قدامنا هنا ده quadratic curve، ده special case، حالة خاصة، لكن احنا عندنا عامة any curve y equal f of x، the first derivative is the slope and the slope equals tan theta. And now choose an arbitrary point a x node and y node, and we want to find the slope of the tangent at this point. So first of all we want to find the derivative of the curve and then substitute by the x equal x node, which is the x of the point, and then you are going to find the theta or the inclination angle. So now let's take an example. Find the slope of the tangent of the curve whose function is f of x equals x power 3 minus 3 at the point a equals 2 and 5. So first of all find the derivative. So 3 will goes down and the power will be 3 minus 1 equals 2. So we have 3x power 2. And the constant negative 3 in the derivative becomes 0. So the first derivative is 3x power 2. And then replace x by 2. So the first derivative at x equals 2 is 3 2 power 2. 3 times 4 equals 12. Now you have tan theta equals the slope. So tan theta equals 12. Then theta equals tan inverse for 12. Use your calculator. So theta equals 85.23 degree. The second application is determine the equation of the tangent of a curve at a given point. So this is the first form and it's very easy. The second form is also a very easy form, y equals mx plus c. Y equal mx plus c. Y is the slope and c is y-intercept. The tangent is a line and the equation of the line has two forms. The first form is y minus y node equals m times x minus x node, where m is the slope of the line. This form is very easy because the slope equals tan theta. So if you divide x minus x node, so you have y minus y node over x minus x node equals m. So m equals tan theta delta y over delta x, which is opposite over adjacent. The second form is y equals mx plus c, where m is the slope and c is y-intercept. So let's take an example. Find the equation of the tangent to the curve whose function is f of x equals x power 2 minus 3x at the point a equals 1 and 4. So first of all we want to find the slope of the tangent. So we are going to get the first derivative. 2 will goes down and we have 2x. Negative 3x will be negative 3. So the first derivative is 2x minus 3. And then use the point 1 and 4. Use x of the point, which is 1. So the first derivative at x equals 1 equals 2 times 1 minus 3 equals negative 1. So the slope at this point, the slope of the tangent at this point is negative 1. Now the equation of the line is y minus y node equal m times x minus x node. Here x node equals 1, a equals 1 and 4. So x node equals 1 and y node equals 4. So the equation of the tangent is y minus y node, which is 4, equals negative 1, which is m, times x minus 1, which is x node. So y minus 4 equals negative 1 times x minus 1. This equation can be simplified to be y equals negative x plus 5. Negative 1 times x equals negative x. Negative 1 times negative 1 equals 1. 4 will goes to the next side. You have 1 plus 4 equals 5. So this is the form y equal mx plus c. Now we have the third application is determine the equation of the normal to the tangent at a given point. So the normal is a line and the equation of the line is y minus y node equals m times x minus x node, or y equals mx plus c. And since the normal and the tangent are perpendicular, then the slope of the tangent times the slope of the normal equals negative 1. So if you have the slope of the tangent, you can find the slope of the normal. So let's take an example. Find the equation of the normal to the curve whose function is f of x equals 2x power 2 plus 1 at the point a equals negative 1 and 3. So first of all, you are going to get the first derivative. 2 times 2 equals 4, so 4x plus 0, because 1 is constant and the derivative of the constant equals 0. So the first derivative is 4x. Then you are going to substitute by the x of the given point. So the derivative at x equals negative 1 is 4 times negative 1 equals negative 4. Then the slope of the tangent equals negative 4. And to get the slope of the normal, you are going to make two changes. First, you are going to change the sign and then you are going to flip. So the slope of the normal equals 1 over 4. You change the sign, it becomes positive, and then make multiplicative inverse, so it becomes 1 over 4. So the equation of the normal is y minus y node equals m times x minus x node. X node and y node are the coordinates of the given point. M is the slope of the normal. So here we have y minus 3 equals 1 over 4 times x plus 1. Minus 1 is positive 1. And this equation can be simplified to be y equals 1 over 4x plus 13 over 4. Now we have the fourth application. Determine the critical points for a curve. The critical points are the points where the curve is flipped. Here we have the curve is increasing, and after this point it becomes decreasing, and after this point it becomes increasing again. Also, the critical points are the points where the tangent is parallel to x-axis. And when a line is parallel to x-axis, then its slope equals 0. So to get the critical point, you are going to get the slope of the tangent, which is the first derivative of the function, and then you have an equation where the slope equals 0, and then you are going to get the critical points. To understand this, let's take an example. Find the critical points. or may be named as saddle points or inflection points. So find the critical points for the curve f of x equals negative x power 3 plus 3x power 2. So first you are going to find the first derivative and make it equal to 0. So the first derivative is negative 3x power 2 plus 6x equals 0. So now we have a quadratic equation, and to solve this equation you are going to use the general formula or use your calculator. So x1 equals 2 and x2 equals 0. So you have two solutions, x1 equals 2, first solution, x2 equals 0, second solution. And then you are going to substitute by x1 and x2 to get y1 and y2. So at x equals 2, we have negative 2 power 3 plus 3 times 2 power 2 equals 4. So the first critical point is 2 and 4. The second critical point you are going to use x equals 0. So we have negative 0 power 3 plus 3 0 power 2 equals 0. So the second critical point is 0 and 0. The fifth application is determine the type of the critical points. The critical point may be local maximum or local minimum. So to determine whether the critical point is maximum or minimum, we are going to use the second derivative. If the second derivative at the critical point is negative, less than 0, then the point is maximum point. And if the second derivative at the critical point is positive, more than 0, then the point is minimum point. To understand this, let's continue the previous example. In the previous example, we got the critical points for the function f of x equals negative x power 3 plus 3x power 2, and the critical points were 2, 4 and 0, 0. Now we want to determine whether the critical point is maximum or minimum. So we are going to get the second derivative, which is negative x plus 6. And then we are going to use the critical points. The first critical point is 2, 4, so the x coordinate of the first point is 2. So the second derivative at x equal 2 is negative 6 times 2 plus 6 equals negative 6. And since the second derivative is negative, then 2, 4 is a maximum point. And then use the second point. The second point is 0, 0, so the x coordinate of the second point is 0. So the second derivative at x equals 0 is negative 6 times 0 plus 6 equals 6. And since the second derivative is positive, then 0, 0 is minimum point. The sixth application is determine the interval of increasing and decreasing. In the previous example, we have two critical points for the curve negative x power 3 plus 3x power 2, and the 2 points are 2, 4, and this point is maximum point, and 0, 0 is minimum point. And now we want to find the increasing and decreasing intervals. And as you see in the opposite graph, at the interval negative infinity to 0, the curve is decreasing, and after the critical point, the curve is flipped. So in the interval 0 and 2, the curve is increasing. I hope that this video is useful to you and that all of you understand the applications for the first derivative. And see you soon in the next videos, inshallah. And don't forget to support my channel, like and subscribe.